Questions 21 through 25 on the 2017 Grade 7 Gauss Math Contest. Rectangles that measure 4 by 2 are positioned in a pattern in which the top left vertex of each rectangle, after the top one, is placed at the midpoint of the bottom edge of the rectangle above it, as shown. When a total of 10 rectangles are arranged in this pattern, what is the perimeter of the figure? So here we go, not perfectly drawn to scale, but here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those 4 by 2 rectangles positioned exactly the way they've described it in the question. So now we will have to figure out the perimeter of the shape. Okay, well that perimeter from there to there, just that part, is 4. Similarly, that part is going to be 4. So we've got to figure out all the sides. This is going to be 2, this is going to be 2, right? Because those are positioned in a way so that they even show you on the diagram that this is equal to that. And since the whole side is 4, then each of those is going to be 2. So let's just count up how many of those 2's we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we've got the perimeter so far looks like 4 plus 19 of those 2's plus the 4 at the bottom. And now let's count the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Which is what I thought. So this looks like 8 plus 38 plus 38, and therefore that is 84. So number 21, the answer is D. If the 6-digit number 1, A, B, C, D, E, each letter represents a digit. Given that 1 A, B, C, D, E times 3 is equal to A, B, C, D, E 1, the value of A plus B plus C plus D is. We have to fiddle around with this, and let's see what happens. So, in the standard way that you first learned multiplication, A, B, C, D, E, 1. Okay, here we go. So, the first column tells me that 3 times E has got to be equal to 1. Well, all of these are integers, right? Well, they're digits, which are integers, but this is not possible with an integer. So, 3E can't equal 1. It could equal 11, but again, it wouldn't work. But when you make it equal to 21, that's when it works. E becomes 7. So that 7 is something that is going to help us. So I'll just put it right below right there. So that's basically representing the value. Okay, let's keep going. So that means 3 times D plus the carry, right? Because 3 times E is going to be 21. So you put the 1 here, but then of course you got to carry the 2. So in that style, 3 times D plus 2 has got to be equal to that E, which is 7. Okay, well 3D therefore equals 5, but that's not possible, right? Because D's got to be an integer. So that means 3D plus 2 perhaps could have been 17, right? So 3D equals 15, D equals 5. That works in terms of an integer. So D equals 5. So I'll put the 5 here, put the 5 here to represent what the value of D is. Let's keep going. And this time there was a carry. 3 times D is 15. And then we had to add the 2, make it 17. So the carry is just a 1. Keep going here. 3C plus 1 is equal to 5. Well, that means 3C is equal to 4. Well, that doesn't work. So 3C plus 1 perhaps is 15. Let's see. 3C equals 14. That doesn't work. 3C 25. 3C plus 1, I should say. And therefore 3C is 24. That works. C becomes 8. Okay, so let's put that in there. C is 8. C is 8. Is there a carry? 3 times 8 is 24. Plus the 1, 25. We put the 5 here, and then therefore the carry goes here. That's a 2. Okay, next one would be 3 times B plus 2 is equal to this C, which is 8. Does that make sense? Yeah. 3B is equal to 6. B equals 2. Okay, great. So that's a 2, that's a 2. And I think we just have one letter left. Is there a carry? There's no carry, right? Because it's 3 times 2, which is 6 plus 2. Yeah, so there's no carry this time. So the last one looks like 3 times a, no carry, is equal to 2. Well, that's not going to give you any integer solutions. How about 12? That will give you 4. That will work. So a is 4. And there we go. We got it all. So now we got to figure out a plus b plus d plus c. Okay, so that's going to be 4 plus 2 plus 8 plus 5 plus 7. And that is equal to 26. So number 22, the answer is B. Given 8 dimes, 10-cent coins, and 3 quarters, 25-cent coins, how many different amounts of money can be created using one or more of the 11 coins? Here you have a very nice table. This row represents the number of dimes from 0 to 8. This column represents the number of quarters from 0 to 3. And then for each combination is listed the value. So for example, if you had 2 dimes and 2 quarters, that would be 70 cents. Now, as you can clearly see, there's 9 numbers there and 4 numbers there. So 9 times 4 is 36. But 36 is not even one of the answer choices. Why? Because we have to eliminate some. The first one we eliminate is this guy right here, because that uses 0 quarters and 0 dimes, and that's not allowed because we have to use at least one or more of the 11 coins have to be used. And then this is the key word here of the question, different. So some of these are doubles. As you can see, there's a 70 here, there's a 70 there. There's a 75 here, there's a 75 there. So you got to eliminate the doubles. Can't count them more than once. So when you do, you cross out these guys. These 8, as you can see, are clearly crossed out already. Those are doubles. So from this 36, you got to subtract that 1 for this guy, that's 0. And then you got to subtract those 8 doubles. So it's 36 minus 9, which is 27. And therefore, number 23, the answer is A. Four vertices of an quadrilateral are located at 7, 6, negative 5, 1, negative 2, negative 3, and 10, 2. The area of this quadrilateral in square units is. Let's draw a quick sketch. Doesn't have to be a masterpiece, but just to get an idea of what this looks like. Very rough sketch. So 7, 6, approximately here. Say 7, 6. And then negative 5, negative 1. So negative 5 and then 1. So right here approximately negative 5, 1. And then negative 2, negative 3. So negative 2, negative 3 about here. And then finally we've got 10, 2. So perhaps here 10, 2. Now this is a quadrilateral, not necessarily a rectangle. So don't assume that it's a rectangle. So when you add up the points, you get a shape like that. Okay, well, at this point, I'm not really sure where to proceed, right? We have no idea. Quadrilateral simply just means 4 sides. Doesn't mean rectangle, doesn't mean anything. So we have to figure out the area by first calculating the side lengths and getting some sort of a understanding. Okay, let's talk about that side length. That'll be 10 minus 7 using the distance formula, and then 2 minus 6. So that distance will be that formula. So that looks like 9 plus 16. So that's just square root of 25, which is 5. Okay, so I'll put a 5 there. Let's do the same thing over here because I've got to figure out what kind of shape this is. So using the same distance formula, negative 2 plus 5. And then minus 3 minus 1 all squared. So this gives me 9 and then 16. So that is again 5. Okay, that's very helpful that is 5. So let's now figure out these two sides, those lengths. And that would be 7 minus 1 squared plus 6 plus 5 squared. Sorry, 7 plus 5. Don't make that mistake. And then 6 minus 1 squared. All right, so this is 144 plus 25. That's 169, so that's 13. And then finally, let's do the same thing with the other side. So 10 plus 2 squared plus 2 plus 3 squared. And again, that gives me 144 plus 25. And therefore, that's 13. Okay, great. So that's very helpful because that means this is either a rectangle or a parallelogram. And the only way this would be a rectangle is if, of course, this was a right angle. Now, I don't know if it is. So what I can do is test. If it's a rectangle and that is a right angle, then that would mean by Pythagoras, this squared plus this squared would equal that squared. Okay, let's test it out. Well, first I have to figure out what the length of the diagonal is. That diagonal would be 7 plus 2 squared is equal to 6 plus 3 squared. Sorry, not plus. It's not equals, plus. And this is 981 plus 81, so 162 root. So let's see here. 13 squared plus 5 squared, is it equal to 162 root squared? And that's going to be 169 plus 25, so 179, 180, and 194 does not equal 162. So that means this is not a right angle. So it's not a rectangle. It's a parallelogram. All right. Well, because it's a parallelogram, that means we got to do a little bit of work here. So the shape is basically like this. Something like that, right? It's a parallelogram. So in order to figure out the area, we've got to figure out that perpendicular distance. But we've done quite a bit of work. We've done that. That's 13, and we figured out that this is 5. And we know that this is negative 5, 1. We know that this is 7, 6. We also know the other coordinates are 10, 2, and negative 2, 3. If I can figure out the coordinates of this point right here where that altitude meets the other side, I'll be able to figure out the area. I'll call this h for height. The area would just be 13 times h. That's it. So if I can figure out that h, I'll be done. Now, how do I figure out this point right here? Well, I need to figure out the intersection between those two lines. So I have to figure out the formula. First, let's figure out the formula of that line. I have 2 points. Y equals mx plus b is the equation. I can substitute in the first point and the second point. So the first point would give me 1 is equal to minus 5m plus b. The second point, 7, 6, would give me 6 is equal to 7m plus b. And then if these guys are subtracted, we would get 5 is equal to 12m plus the b's cancel, so m is going to be 5 over 12. Substitute that value of m back into either one of those, and we would get a value of b of 37 over 12. So that first equation is y is equal to 5 over 12x plus 37 over 12. Great. Now let's calculate the equation of that formula. That formula, again, y equals mx plus b. Right, that's the form. But the good news is the m is the perpendicular. The line is perpendicular, so the slope is the negative reciprocal. The negative reciprocal of this, which would be, first you take the reciprocal, so 12 over 5, and then you take the negative. That's what it means, negative reciprocal. So very quickly you can figure out the slope of that line. And then x plus b. To figure out b, we just substitute in that point. Negative 2, negative 3. And when you calculate b, you get minus 39 over 5. So that equation is y is equal to minus 12 over 5x minus 39 over 5. So now we set these equal to each other, and that will allow us to figure out the intersection point. So minus 12 over 5x minus 39 over 5 is equal to 5 over 12x plus 37 over 12. Solving, we get a not so great number, minus 653 over 169. Let's just convert that into a decimal. Minus 3.8639. I think 4 decimal places would be good enough. Substitute this back into either one of these equations, either this one or this one, to get the y value. And when you do, you get y is equal to approximately 1.4733. So we got this point right here. Whatever that point, wherever it is, its coordinates are x is minus 3.8639, and the y coordinate is 1.4733. So now we can easily figure out h. H will be minus 2 plus the 3.8639 all squared plus minus 3 minus 1.4733 all squared, and then you take the square root. So h, when you do that math, you get approximately 4.84. Okay, so now let's just put it there. 13 times 4.84. And that is 62.92. And I had rounded quite a bit here. But when you do this exactly, you'll get, that's pretty much 63. And therefore, number 24, the answer is B. Ashley writes out the first 2017 positive integers. She then underlines any of the 2017 integers that is a multiple of 2, and then underlines any of the 2017 integers that is a multiple of 3, and then underlines any of the 2017 integers that is a multiple of 5. Finally, Ashley finds the sum of all the integers which have not been underlined. What is the sum? This is a very interesting question. So initially we have 1 plus 2 plus 3 all the way up until 2017 if you were going to add up all the numbers. And throughout this question, I'm going to use a formula that I'm sure some of you or most of you may know. That is, if you add up all the numbers 1, 2, 3 up until n, that is equal to n times n plus 1 divided by 2. So in the beginning, I've got all these numbers until 2017. So using this formula, that's going to be the sum 2017 times 2018 divided by 2. Correct? And that is 2035153. All right. So now we have to take away all the numbers that are divisible by 2. Because remember, all the numbers that are multiple of 2 she underlines, and at the end we have to figure out the sum of all the numbers which have not been underlined. So essentially you're just removing those numbers. All the numbers that are multiples of 2 are of the form 2, 4, 6, 8. And then we have to figure out what's the final number. Well, it'll go all the way up till 2016, right? Because 2017 is not a multiple of 2. Okay, well, how do you add up these guys? Factor out a 2. And then you'll get 1 plus 2 plus 3 plus dot until 1008. And then you can apply that formula. It'll be 2, but that is just going to be using that formula. So 1008 times 1009 all divided by 2. And this is 17072. But remember, in the sum, we have to subtract these guys because these numbers will be underlined. And at the end, we have to add up the numbers that were not underlined. Okay, then she underlines multiples of 3. 3, 6, 9, and so on. And then we have to figure out how far do we go when we underline multiples of 3. And you go until 2016 again. Well, how do I figure out this sum quickly? Factor out a 3. And when you do, you get 1 plus 2 plus 3 plus ... until 672. Again, we'll use this formula. So it's 3, but then this is just going to be using that formula 672 times 673 divided by 2. And this big long number is 678,384. And remember, these guys we have to subtract because these were underlined. And the underlined numbers are not going to be counted at the end. We have one more, and that's 5, multiples of 5. So 5, 10, 15, so on, right? And that's going to go all the way till 2015. Again, by now I think you're an expert. Factor out the 5. That'll be 1 plus 2 plus 3 plus ... 2015 divided by 5 is 403. Okay, now let's use the formula again. So we have basically a 5 out front, and then we have 403 times 404 divided by 2, and that is 407030. And we have to subtract these. Okay, now, are we done with the question? And the answer is a big no. It's not that simple. We've done everything correctly, but there's a few more steps. All right, well, what are the steps? Well, I'll explain. So far, everything's fine, but you see there's a 6 there? There's a 6 here also. So that means we subtracted the 6 twice. And similarly, any number that is a multiple of both 2 and 3 would have been subtracted twice. And therefore, since we subtracted those numbers twice, we had to add them back once, right? I subtracted 6, I subtracted 6 again. So I've got to add back 6. You see what I'm saying? So subtract, I've got to add. So any number that is a multiple of 2 and 3, I subtracted twice, I've got to add it back. So what are those numbers? Multiples of 2 times 3 are multiples of 6. So 6, 12, 18, and ... So we go all the way up until 216 because that's the largest multiple of 6. All right, here we go. Again, factor out the 6, and we get 1 plus 2 plus 3 all the way up until 2016 divided by 6 is 336. So, again, we use our formula. 6 times 336 times 337 divided by 2, and that is going to be 339696. And this one, remember, we have to add back. We're adding one of those back, one of those multiples of 6. We had subtracted it twice, so we got to add it back once. All right, so now we have to do the exact same thing, but this time for multiples of 2 and 5. For example, 2 and 5 is 10, right? So there's a 10 in here because it goes 2, 4, 6, 8, 10. And there's a 10 in here because it went 5, 10, 15. So as you can see, we subtracted the 10 here, we subtracted the 10 there. In a very similar way, because we subtracted the 10 twice, we have to add it back once. So the same kind of story. 10 plus 20 plus 30, all these guys were subtracted twice, so we have to add them back once. So we're going to go up to, I believe, 2010. So factor out the 10, we get 1 plus 2 plus 3 plus ... up until 201. And that would give me 10 times 201 times 202 divided by 2, and that is 2031010. And remember, we're adding this guy. And then there's one last one that's a double. We had taken care of multiples of 2 times 3, which are 6. We had taken care of multiples of 2 times 5, which is 10. We now have to take care of multiples of 3 times 5, which is 15. If you notice, in this list up here, 3, 6, 9, 12, 15, there's going to be a 15 in there, and there's a 15 in here. So we had essentially subtracted the 15 twice, so in the same way, we've got to add it back once. So 15, 30, 45, all these multiples of 15 have to be added back once. And it goes all the way up until 2010 again. 2010 is a multiple of 15. Factor out the 15, 1 plus 2 plus 3, all the way up until 2010 divided by 15 is 134. So using our formula, we got 15 times 134 times 135 divided by 2. And this number is 135675. And that number, of course, we have to add back. Okay, are we done? The answer is no. We have one more number that we have to either add or subtract. And this one, I think some of you might have been able to figure it out, but if you haven't, no problem. It's numbers that are multiples of 2, 3, and 5. Multiples of 2, 3, and 5. So the smallest one would be 2 times 3 times 5, which is 30. And what's interesting about 30 is that it appears in all 3 lists. It would appear in this list somewhere in here because it's a multiple of 2. It would appear in here somewhere because it's a multiple of 3. It would appear in here because it's a multiple of 5. So if you notice, we subtracted it here, and we subtracted it here. But then we added it back here because 30 is a multiple of 6. We added it back here because 30 is a multiple of 10. We added it again back because 30 is a multiple of 15. So essentially we subtracted it 3 times and we added it 3 times. So we haven't really taken care of it yet. You subtracted 30 3 times, you added it back 3 times. So we have to subtract it once at least. So that's what we're going to do. We have to now subtract the multiples of 30. So 30 plus 60 plus 90, ... And then what number are we going all the way up until 2010 again? 2010 is a multiple of 30, interestingly. So you are an expert now. Factor it all out. And then 2010 divided by 30 is 67. So using our formula, we got 30 times 67 times 68 divided by 2. And that number is 68,340. And we are doing what to this? Subtracting once. So that's probably the most challenging part of the question. Okay, now we got all our numbers, all of these numbers here, right? We have to add them all up. We'll add and subtract. So we got this one, subtract that one, subtract this one, subtract this one. Then we have to add this, add that, add this, and finally, we have to subtract this. And when you do all that math, you get 5,42708. That is your number. 5,42708. And that is choice A for number 25.